Hi, I'm Catherine Sobocinski, and I'm here to present on the Whidbey Basin Cumulative Effects Evaluation, which is an exciting new methodology put together by a number of people on the research team. So I'm really serving as the spokesperson today for this larger research effort. I'd like to acknowledge my co-authors, Mike Lemoyne, who serves as our PI from the Skagit River System Cooperative, Todd Zaki from Tulalip Tribes, Josh Chamberlain and Corey Green from the Northwest Fisheries Science Center, Jason Hall from Kramer Fish Sciences, and Annalise Del Rio from Puget Sound Partnership and myself comprise the research team for this project. In addition, we've received support from a number of other oversight groups, but some individuals in particular have played an important role in developing this methodology. So I'd also like to acknowledge Tish Conway-Kranos from DFW, Heide Diefenderfer from PNNL, who developed much of the methodology that got us off the ground in the first place, Megan Camp from Kramer Fish Sciences, Gary Johnson from Bioanalysts, and Aline Trujillo from Puget Sound Partnership, who's kept us all moving in the right direction. The fundamental question that we're struggling with are what are the individual and cumulative effects of restoration and protection actions? We know that restoration projects are typically implemented at the local scale, and it's really unclear how these restoration projects impact the region at larger scales across the landscape and seascape. We know that in particular, the Whidbey Basin salmon populations intermingle in some habitats, which may make them more valuable when we consider a region as a whole. So I'd like to start by defining what we mean by cumulative effects evaluation and this framework that we're developing. So in the context of ecosystem restoration, cumulative effects are the collective, additive, synergistic, and antagonistic effects of all restoration activities that occur within a setting defined by common or connected characteristics of hydrology, geomorphology, ecology, ecological function, and biodiversity. And this definition came from a report from the National Academies last year. So for this work, we're undertaking a structured evidence-based analysis using multiple lines of evidence and causal criteria syntheses to make inferences about cause and effect relationships between restoration and salmon recovery. This research really stems from two previous efforts. First, an effort in the Columbia River estuary, which Heide Diefenderfer was important in instrumenting over the course of many years, asking the question, what are the benefits to juvenile salmon from reconnecting floodplain wetland to the main stem of the Columbia River? Here they were looking for evidence of programmatic outcomes and a process to assess targets of restoration. The second one was from the Gulf of Mexico and wanted to evaluate restoration response to changes over time. And this came as a result of the Gulf oil spill. And the summary of this activity, although it has yet to be implemented entirely, the question was, how do acute and long-term physical changes affect cumulative effects of restoration actions? And this was in this National Academies report from last year. So building off these two efforts, we wanted to apply a similar cumulative effects evaluation framework to evaluating salmon recovery in Puget Sound. We know that ecosystem recovery is occurring at a variety of scales, and it's necessary to assess performance and hopefully improve on our understanding to target recovery actions further. So methods for understanding the cumulative effects of multiple restoration actions within and across landscapes and seascapes is seen as necessary to making these improvements. In addition, our analysis can leverage existing tools, as described here, to try and take advantage of some of the understanding and knowledge and information that has been come out of each of these restoration projects individually. So why did we choose the Whidbey Basin? So first of all, the Whidbey Basin is comprised of the Snohomish, Stillaguamish, and Skagit River watersheds. It's a major component of Puget Sound, seen here in the green outline, green shading, and the Salish Sea region as a whole. It has a variety of representative habitats within deltas, nearshore areas, and other estuarine habitats that are important for salmon as they undertake their outmigration. So there are three other main reasons why this region was of interest to us. First, it's an important region for salmon populations within Puget Sound, with 10 of the 22 delineated Chinook salmon populations occurring in this subbasin area. There have been significant restoration efforts here as well, well-documented restoration efforts with 36 nearshore and estuarine restoration projects since 1999. There's also been extremely intensive long-term monitoring. So each of these restoration projects has had the goals, actions taken, built evaluations documented, as well as monitoring efforts related to fishes and invertebrates within this region, and also the structures of these restored habitats. So it's an important region in terms of documenting the successes of these restoration projects, and also which ones are seeing more salmon use and effectiveness than others. So in terms of restoration monitoring, we know that there are a number of different projects throughout the basin with multiple years of fish data, especially, as well as some other monitored restoration structures and other attributes. And these occur throughout the subbasin. So if we look at these maps, you can see that the restoration is really spread throughout. So we have really nice spatial coverage within the Whidbey Basin in general in terms of monitoring. So this provides us with the data that's fundamental to taking on a large-scale synthesis effort related to restoration. So I'm going to walk through now the approach that we are using. So this is modified from previous cumulative effects evaluation efforts because we really wanted to leverage this understanding, data, and knowledge from the Whidbey Basin in this process. So the first step was to define our questions and our scope. And our scope we've decided to keep it from the 1990s to present, when most of the restoration actions have occurred within the Whidbey Basin, nearshore habitats, including shorelines, tidal freshwater areas, embayments, and deltas. And our focal species is Chinook salmon, although we are addressing other anadromous salmonids where appropriate and where data are available. So we came up with this overall hierarchy of flow of our restoration cumulative effects evaluation process. We start by outlining our management questions, our research questions, and from there we built conceptual models of each of the components of the study that we wanted to address. From there, we moved into guiding hypotheses. How did we want to break this out so that there was some nestedness within our evaluation framework? From there, we are moving towards building evidence, these lines of evidence for our various hypotheses. And then this will ultimately feed into inference via synthesis. So these hypotheses, we've got them in a hierarchical structure, which will then feed from bottom to top as we start to draw synthesis and identifying modes of cumulative effects and invoking our causal criteria analysis. So our key research questions here are: what are the benefits for listed salmonid populations in the Whidbey Basin from restoration, conservation, and protection actions in the face of continued impacts? We understand that while we've had extensive restoration, there are also continuing losses. Felt that that was important to acknowledge in our research question. The second one is: what are the trajectories of juvenile salmon population characteristics, and how are they linked to habitat improvements in the Whidbey Basin nearshore? So this one specifically addresses how salmon are responding. So I wanted to run through a little bit about our conceptual model. So we came up with an interrelated process for conceptual models where we have 3 explicit conceptual models that helped us really structure our thoughts around how we were going to organize this cumulative effects evaluation and what information we would need. The first model is the life history context model. So that acknowledges that in each of these watersheds, there are different life histories that are expressed predominantly and different modes that salmon use during their outmigration. This feeds into the Whidbey Basin spatial context model, which acknowledges that there is variation within the Whidbey Basin, and that fish using different habitats may be taking advantage of these habitats differentially. The last one was the restoration and process context model. And it was important for us to articulate that this project is specifically related to the outputs of restoration and salmon response to it. In other words, it's not a salmon project agnostic to the effects of restoration. We wanted to explicitly tie the way we were thinking about this to restoration projects. So this is a simple diagram, but I think it's important to show that underlying that simple diagram are some somewhat complex conceptual models acknowledging the different life histories of salmon, the complexity of the habitats that we're addressing in this cumulative effects evaluation, and also how restoration and the context of restoration plays out in terms of salmon life histories. I'm not going to go into these more than flashing them here, but know that they're well documented in our report and in a manuscript that we're working on as well. So this was given a lot of thought as a way to ground our cumulative effects evaluation, and these conceptual models have been useful tools for the research team and for presenting out to outside organizations as well. The next thing was developing our hypotheses. And we used this paper by Hager et al. Called The Hierarchy of Hypotheses Approach, a synthesis method for enhancing theory development in ecology and evolution, as kind of the fundamental underlying structure to how we wanted to build our hypotheses. So we had our tier 1 overarching hypothesis, which is essentially our research question. Within that, we had tier 2, which we considered operational hypotheses, which were focused more around the various outcomes that we wanted to assess. So habitats in terms of structure, the processes associated with habitats, and then salmon survival, distribution and migration, and growth as 3 aspects there. Within each of these tier 2 hypotheses, we had a number of mechanistic hypotheses as well that we were hoping to build out, and that would be specifically testable with the information and data that we have. So those are here. I'm not expecting anyone to look through them, but just know that each of those tier 2 hypotheses are in gray font or in gray background, and then the cascading blocks below those are the individual tier 3 hypotheses nested within those larger subject areas. So that was all built out up until now, and I'm going to start to get into what is ongoing at the moment. So this is still a work in progress. But from those hypotheses, we're starting to develop lines of evidence using the indicators that we have, literature, so empirical data from the indicators, literature, and some modeling results in these areas. So in terms of what I mean by lines of evidence, these are really different approaches to getting at what information is out there related to salmon response to restoration. So we have developed, Kramer Fish Sciences is taking the lead on developing an evidence-based literature review and meta-analysis for restoration effectiveness as well. They're doing a fantastic job synthesizing existing information and pulling out actual quantitative information where possible to undertake this meta-analysis. There's also some target species analysis where we're looking for various things within these restoration projects, especially related to salmon, density, occurrence, abundance, and diets, and those kinds of things. Also, landscape change analysis. So we know that these landscapes have changed over time, and once they were restored, there are different trajectories for each one. So we have a proposal pending for addressing specific landscape change analysis as part of this project. We're also looking at physics-based and ecosystem model outputs for these areas, and then looking at the modeling of cumulative net ecosystem improvement. So how can we take all of these restoration sites across a landscape and start to build this understanding of net ecosystem improvement from these? And then the last one is identifying critical uncertainties, because we know that we don't know everything about everything. And so there are still gaps that might need to be addressed, and identifying those as part of this cumulative effects evaluation. So the last part here is to develop causal criteria, and these were developed and articulated in a paper by Diefenderfer previously in 2016 about ways that we would start to build plausibility of each of these different lines of evidence and how they might be affecting the various aspects of restoration in our tier 2 hypotheses. So adding into this schematic diagram, you can see the causal criteria in the dark gray box, but they include things like plausibility, the results of experiments, the specificity of association, coherence. So are we seeing the same results and the same effects across multiple restoration sites, or are they acting differently? Here's where we start to build the cumulative effects synthesis. So this idea of taking the sum of the parts from each of these individual restoration projects and coming up with some way to evaluate them, given that they are all disparate data sets, and trying to bring them together in a united framework. So just to give a highlight of this flow, again, from our management questions down to our results, through our results, building our lines of evidence and into results of this hierarchical synthesis at the bottom, this is also ongoing at the moment. So multiple lines of evidence are intended to confer kind of built-in redundancy, where each line of evidence functions as an umbrella under which relevant analyses are collected for evaluation of the key hypotheses. So this is the framework we've established, and much of this work is still ongoing, with some proposals pending to continue it further. But this is our way of addressing how these multiple restoration projects within the Whidbey Basin are benefiting salmon. And a few important notes here to wrap up. This collaborative team has been absolutely essential. So the Skagit River System Cooperative, Tulalip Tribes, and NOAA have led in data collection and restoration monitoring. There's years of collective experience in these habitats on this team, and it's really been a very collaborative and novel approach to developing methodology, with everyone chipping in. It's a big question of trying to identify signal from the noise here. The key to being able to do this work, though, is the existing data at multiple scales collected from decades of monitoring. So I always like to state this as a wrap up for these types of projects, because it's really important. This decades of monitoring is allowing us to do this larger scale work. The basin is geographically constrained enough to make a large scale assessment tractable as well. But in light of these attributes, we also know that restoration is surpassed by losses. So this is the reality check. Are we going to be able to detect this signal from the noise in this system? And it's still an open system with lots of ocean and river influence, with processes that are not fully understood and are changing at scales ranging from minutes to decades, especially as climate change is occurring in this region. So this is a novel methodology for synthesis at the basin scale, building from other cumulative effects and related large-scale synthesis efforts, with a focus on juvenile salmon and their critical habitats. So stand by as we continue to undertake this work and hopefully have additional results to present in future years. Thank you.